Gravity is a force that's always been shrouded in mystery, yet we know it's what keeps us grounded to this planet we call home. But what if I told you that gravity isn't just about attraction? It's also deeply connected to our understanding of time itself. In fact, the relationship between gravity and time is one of the most fascinating and complex phenomena in the universe. There are a lot of misconceptions about gravity and time floating around out there. Some people think gravity is just a simple, attractive force, but that's far from the truth. Others believe that time is absolute, that it flows at the same rate everywhere in the universe. But that's not exactly true either. The truth is, our understanding of gravity and time has been evolving for centuries, and it's only recently that we've started to uncover the intricate dance between these two fundamental forces. One of the biggest misconceptions about gravity is that it's just a force that pulls us towards each other. But gravity is so much more than that. It's a warping of spacetime, a curvature that affects everything from the smallest subatomic particles to the largest galaxy clusters. And when it comes to time, there's this idea that it's a fixed, one-way dimension that never changes. But what if I told you that time is not as fixed as you think? Time and gravity are intimately connected, and the way we understand this connection has been shaped by the work of geniuses like Galileo and Newton. But it wasn't until Einstein came along that we started to realize just how deep this connection goes. According to Einstein's theory of relativity, massive objects warp space-time, creating gravitational fields that affect not just space, but also time itself. Massive objects like planets and stars don't just warp space, they also warp time. The closer you get to one of these objects, the slower time moves. It's a phenomenon known as gravitational time dilation, and it's been observed and confirmed through countless experiments and observations. From the gravitational redshift of light emitted by white dwarfs to the clocks on orbiting satellites, the evidence is clear. Gravity warps time. But just how extreme can this effect be? Take the example of GPS technology. GPS relies on a network of satellites orbiting the Earth, and these satellites are subject to the gravitational pull of our planet. In fact, if left uncorrected, the gravitational time dilation would cause the satellite clocks to drift by as much as 38 microseconds per day. That might not sound like a lot, but over time, it would add up, and GPS navigation would become useless. It raises all sorts of mind-bending questions about the nature of space and time itself. So what does it all mean? Well, in a nutshell, gravity warps time. From the behavior of black holes to the expansion of the cosmos itself, gravity's warping of time is a thread that runs through it all. Thanks for joining me on this mind-bending journey into the world of gravity and time.